Hello everyone, welcome you all to today's class, and today we are going to start second session of the topic, right? So we have studied in first session, we have covered what is a set, how to denote a set, representation of set, and types of sets. Okay, so in types of sets we have covered what is a finite set, what is infinite set, and what is an empty set. So in continuation with that, today we are going to study what is a subset, then superset, then after that we continue with power set and everything. Okay, so let us begin the class. Okay, so coming to the starting of the class, starting concept, we will start with subsets. Okay, so what is a subset? Yeah. So as you are able to, are you able to see my screen? Yes. Yeah. So for two sets A and B, A is a subset of B if every element of A is an element of B. I'm repeating this. For every element of set A, okay, if every element of set A is an element of set B, then we can say A is a subset of B. And we write it like this. We write it as A is a subset of B, like this. Okay. Now, to how to visualize, I mean, if you want to see how the subsets look like, okay, let me show you. Okay, we'll come down. So, yeah. So, when we write like this, so for example, let me take the example of, suppose you have the set A is set A equal. So, A is a set whose elements are 1, 2, 3, 4. Okay. So, let me take another set B. It is 1, 2, 3, 4, 5. It means every element of A is an element of B, right? So here we can say A is a subset of B, okay? And when A is a subset of B, it means B contains A, okay? And there may be cases like this. Yeah, so you will come across another symbol also, like this. So we call this A is a proper subset. A is a proper subset of B. Okay, A is a proper subset of B. So here also the same criteria. Every element of A is an element of B. Now the difference between subset and proper subset is what? So we can say it is a strict subset, right? Whenever we write A is a proper subset of B, it means it is a strict subset. It means here A cannot be equal to B. Every element of A is an element of B, okay, but A is not equal to B. But in this case, when we say A is a subset of B, here you can see every element of A is an element of B. It means here we are writing this A is a proper subset of B, and this one, the symbol, here A may be equal to B also. Just like now, suppose two numbers A less than B or A less than equal to B. Yeah, A greater than B, A greater than equal to B. So whenever we say subset, so A is a subset of B and A may be equal to B also. Is it clear? And whenever we say proper subset, it is a strict subset. Here, A cannot be equal to B. Now, when A is a subset of B, if you write like this, A is a subset of B. we can say B is a superset of A. In other words, every element of A is in B. It means A is contained in B. Or we can say B contains A. So B is the superset of A. Similarly, B can be proper superset of A also. Is it clear? Now it is all about subset and proper subset. Yes, superset and proper superset. Okay, and we'll take some examples also. Okay. So from these, yeah, so here I've taken some pictorial representation. Yeah. So two sets A and B in this figure. So here you can see B contains A, or every element of A is in B. Yeah, A is contained in B. Here we can say A is a subset of B. Okay, now here you can see, now if I name it as A and B, the bigger one is superset because B here B set it contains A. Just like if we say class 11, class 12, okay, so classes 11 and 12, these two classes are contained in the school. It means school contains all the classes. So if I say every student of class 11 is a student of the school, every student of class 12 is a student of the school. So we can say, I mean, if I write here X such that X is a student of class 11, and the school I take it as X such that X is a student of the school. So if I write like this, suppose I write A is a set whose elements are X such that X is a student of X is a student of class 11. Now let me take B. B is a set whose elements are X such that X is a student of the school. Okay, the school. Yeah. Suppose we take it is class 11 of our school and this is our school. So here you see any student of the class is a student of the school. It means school contains the class. So here we can say A is a subset of B. Okay, now you may be wondering when to write proper subset and when to write this. Okay, so as I said, whether you write A is a proper subset of B or A is a subset of B, in both the cases, the condition is every element of A is an element of B. The only difference is in case of proper subset, we do not take equality sign. It means in case of proper subset, A is not equal to B. In case of subset, A may be equal to B. Okay, and also when we say school contains the class, all the classes. Yeah, every student of class 11 is a student of the school. So school contains class 11. So it means class is subset of the school and school is the superset of the class. Okay, because school contains all the classes. Is it clear? So in this example, you can say A is a subset of B, B is a superset of A. So I hope the concept of subset and superset is clear. Okay, so before going to the next concept, so let me take some examples also. Yes, we can write here. Yeah, some observations we can say. First observation is, so we can say every set is subset of itself. Okay, you can write here every set is a subset of itself. Subset of itself. It means if I write here set A, every element of set A is an element of set A. So A can be taken as subset of A. But here we cannot write proper subset. Okay, we cannot write A is a proper subset of A because A is equal to A also. Right? So every set is a subset of itself. Second thing is, by default, we take phi is a subset of every set. Okay, or you can write empty set is the subset of every set. So this is, I mean, when we take empty set, obviously empty set doesn't have an element, right? A set having no element is called empty set. So we cannot show the elements here because it doesn't contain any element. So as a trivial, case, or you can say by default we consider this empty set is subset of every set. Okay. Third observation, if A is a subset of B, then B is superset of A. Okay. Now next thing is, we can say universal set. Okay, so universal set. So in universal set, see, as you know, universe, it contains everything. It contains all of us, right? So from universe, it is, you can say universal set. Just to, relate. Okay, so universal set, it means it is the bigger set. You can say it is the superset of all the sets. We denote it by U. Okay, universal set denoted by U. So what is universal set? It is a set containing, all the sets under consideration. All the sets under consideration. So what does it mean by under consideration? It is the set which contains all the sets under consideration. So it means set containing all other sets basically. Suppose for example, why I'm using the term under consideration? For example, you see, if you take class 12th, class 11, class 10, class 9, maybe you can go till nursery class. Okay, so here school contains all the classes. School is the superset of all other classes because school contains all the classes. So if we write here class 10th set A, class 11 set B, class 12 set C, and so on. So as every student, a student of any class is a student of the school, so we can take like this. So every class is a subset of the school. It means school is superset of all the classes. So it means here in this case, school can be taken as the universal set when we consider all the classes of the school. Okay, another example maybe we can write like this. So if I write here set of natural numbers, set of whole numbers, set of integers, okay, set of rational numbers. Everything is contained in set of real numbers. It means in this case, set of real numbers can be taken as universal set. So basically, what do we understand from this? So basically, the basic concept here is universal set is the superset of all other sets. Okay, and it depends from case to case. Like I have given one example. Whenever we are considering the classes of the school, in that case, school is the universal set. When we are considering the number system, natural number, whole number, integer, I mean all these sets, set of real numbers contains all these sets. So here, set of real numbers is the universal set of this. And another example also, suppose we are given set 1, 2, 3, 4, 5, 6, and we can take up to 10. Okay, this is set A. Now let me take it as like B set 1, 3, 5, 7. Okay, C set equal to 2, 4, 6, 8, 10. And D set is, you can write here, 7, 9, yeah, like this. So here if you observe, A contains, set A contains B, C and D. Now in this case, A will be taken as universal set for B, C and D. Okay, for set B, set C and set D, A can be taken as universal set. Is it clear? So basically universal set is the superset of all other sets, right, in that particular situation. Okay, so I would like to take some questions from NCERT. Okay, so which will really help you whatever you have studied. Yes. You can go to exercise 1.3. So there are some questions here. Yeah. So maybe if you go to the first question, yes, exercise 1.3 NCERT textbook. Question number 1, I'll take 2 or 3 parts. Make correct statements by filling in the symbols. Is a subset or is not a subset. Okay, so first part we are given here 2, 3, 4, 2, 3, 4. This is the set. Okay, fill in the blanks. Another set is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so you can check whether it is a subset or not. So every element of this set is an element of this set. 2 belongs to this. 2 also we have here. 3, 3, 4, 4. Every element of this set is an element of this set. So it is a subset. Okay, and similarly, if you write your X is a student of class 11 of your school, okay, it is third part. The other set is X such that X is a student of the school. Okay, so as we have just discussed, every student of class 11 is a student of the school. So it can be a subset. X is a triangle in a plane. The other set is X is a rectangle in the plane. Okay, and obviously it will not be a subset, right? Set of all triangles cannot be contained in the set of all rectangles. That is the reason. And if you write here, another example here, ABC, other, this is the blank, other set is BCD. Can this be a subset of this? Which symbol to be put here? Yeah, ABC, here BC we have. But every element of this should be an element of this. Now here, A is not here. It means this is not a subset of this. Okay, so now you can identify whenever you are taking two sets, whether one set is subset of the other or not, you can identify. Okay, so you can examine whether the following statements are true or false. So you are given, it is question number 2. You are given A, B. Okay, so and this is not a subset of BCA. Okay, so you have to tell whether the statement is true or not. So A is here, we have A here, B is here, then we have B is here. So every element of the first set is an element of the second set. So first set is a subset of this. But here we are given it is not a subset. It means the statement is false. Okay. Second part you can check. So here you can say AE. Set containing two elements AE. This is a subset of the set X such that X is a vowel in the English alphabet. In the English alphabet. So here you can say whenever we say X such that X is a vowel in the English alphabet, as you know, it can be taken as A, E, I, O, U. Okay, so here you see A, E, every element of the first set is an element of the second set. So here it is a subset. It means the statement is true. Okay, similarly, you can check other statements. Coming to the third question. Yeah, so you have to see correct or incorrect. Third question is you are given A, the set 1, 2. Just observe it. One element is set containing 3, 4, then 5. Okay, so first part is 3, 4. This is a subset of A. You have to tell correct or incorrect. And why? Okay, second part is 3, 4. It belongs to A. Third part is 3, 4. Like this, observe the use of bracket also. It is a subset of A. Okay, and you can check 1 belongs to. Fourth part is 1 belongs to A. Okay, fifth part is 1 subset of A. Proper subset of A. Okay, in first case, maybe we can take these things. So here, this is a subset of A. Is it correct? See here, you have set A, one element is 1, then 2, then the double term set 3, 4. Okay, this is your an element of A. Then 5. Okay, so when it is given 3, 4, this one, so this is an element of this. So it cannot be subset of this. Okay, so this is incorrect. The correct one is what? If you want to rectify the statement, 3, 4, this is here, it belongs to set A. Second part is correct, obviously, this is correct. Third one is, you see, this is a subset of A. Is it correct? Whenever you write like this, here you see, it is the element of A. And when you write like this, here, this set containing 3, 4, it is taken as an element of this set. So you can see the double bracket here. So when we write, this is a subset of this, I mean, this one subset of A. So every element of this, so every element means element of the first set is the set containing 3, 4. Okay, that is in A. So it is a subset of A. So this is correct. Now 1 belongs to A. Yeah, 1 is an element of A. Correct. 1 is an element of A. Correct. 1 is a subset of A. No, because 1 is an element. Here, this is not a set. Okay, whenever we take subset for two sets A and B, A is a subset of B if every element of A is an element of B. So when we say for two sets A and B, right, it means when you take two, I mean A subset of B, A should be a set, B should be another set. And every element of A should be an element of B. I'm sure you are, getting the concept. Okay, so we have studied subset. So it is most probably it's done. Okay, universal set also we have studied. Okay, then question number 8 of this exercise 1.3. What universal set would you propose for each of the following? So for each of the following means you are given first set of right triangles. The set of right triangles. Set of right triangles in the plane, and second part is the set of isosceles triangles. So what universal set you should propose? So it means which set can be the superset of these two. Okay, so here you can say the universal set should be the set of all triangles in the plane. Okay, set of all triangles. Okay, so it means the set of all triangles, it contains set of right triangles, set of isosceles triangle also. Okay, so we can propose universal set like this. Okay, now 9th question you can see, I think you can answer this also. Given the sets A, you can say 1, 3, 5, B, 2, 4, 6, C, 0, 2, 4, 6, 8. Which of the following may be considered as universal set for all the three sets A, B, C? So I can write here 9th question of this exercise. A is 1, 3, 5. Set B is 2, 4, 6. Set C is 0, 2, 4, 6, 8. Okay, so which of the following? You are given 4 options. Okay, so you can just see the book if you have the book right now. So here the universal set for all the three sets can be taken as I think this fourth part 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10. This can be taken as the universal set here because this set contains all the three sets. Okay, and all other sets you are given 5. 5 can't be the universal set, and 1, 2, 3, 4, 5, 6, 7, 8. Then 0 is missing here. We can take first part also 0, 1, 2, 3, 4, 5, 6. Then we do not have 8 here. So that's why we cannot take it. Okay. So is it clear? I mean, what is a subset and what is superset, and also what is universal set? Okay. Then whenever you are given, suppose for example, we are given A that is equal to, maybe I can write here 2 elements. Okay. So now the concept, the thing I want to ask you, how many subsets are possible? Okay, yeah, what are the possible subsets of A? Okay, what are the possible subsets? What are the possible subsets of A? Okay, this is the question. So, I mean, we have to find all possible subsets of A. Now, if I write it 1 here, it is a subset of A. And if I write 2 here, again it is a subset of A. If I write 1, 2, it is a subset of A. And if I write 5, empty set, subset of every set. So it means when number of elements in A is 2. Okay, number of elements in A equal to 2. You can see how many subsets are possible. number of subsets equal to 4 means 2 square. Now let me take, if I write here only one element, okay, A equal to this. Now number of subsets. So what will be the subset of this? Every set is a subset of itself. Phi subset of every set. Okay, so it means number of elements in A equal to 1, number of subsets, number of possible subsets equal to 1, and I mean this and this. You are getting 2, means 2 to the power 1. If I write here A equal to, it is having 3 elements, 1, 2, 3. So let us find all possible subsets. So 1 is a subset of A, 2 is another subset of A, 3 can be taken as, I mean these are sets we are taking, just observe. Okay, if I write here 1, 2, set containing 1, 2, subset of A, set containing 2, 3, it is a subset of A, set containing 1, 3, it is a subset of A. If I write here 1, 2, 3, okay, 4 set, it is a subset of A. 5 is also subset of A. Now let us count how many subsets we are getting. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it means when A has 3 elements, number of subsets equal to 8. So it means number of elements in A equal to 3, number of subsets of A equal to 8, that is equal to 2 to the power 3. 2 raised to the power 3. Okay, it means from these examples what we can conclude? So if number of elements in A equal to n, if A has n elements, then number of all possible subsets of A, number of all possible subsets of A equal to 2 raised to the power n. So if the question is how many non-empty subsets can be possible? Okay, so let me write it here. So here you can say number of non-empty. So non-empty subset means 5 will not be included. Number of non-empty subsets equal to, we can check when you have 3 elements here, you have 8, and out of 8, this is empty subset, right? So 5 is a subset of A. 5 is an empty set. Okay, so whenever we want to consider non-empty, so we cannot take 5. It means the number of subsets will be whatever 2 to the power n less than, 1 less than that. So you can see here number of all possible subsets of A, when A contains n number of elements, you have 2 raised to the power n. If the question is specifically how many non-empty subsets, then you can write 2 raised to the power n minus 1. Okay, you can see from here, and all the 3 examples you can see also. So basically, whenever it is all possible subsets, we are including 5. When it is only non-empty subsets, 5 will not be included. Okay, so it means number of non-empty subsets of A having n number of elements will be 2 raised to the power n minus 1. Okay, so now this is the time to introduce power set. What is power set of a set? power set. We can write power set of a set A denoted by we write like this. Okay, power set of A is a set whose elements are is a set whose elements are all the subsets of A. All the subsets of A. So all the subsets means empty and non-empty. Okay, so now we know how to find all possible subsets of A. So whenever you have all the subsets of A, then the set containing all the subsets of A will be power set of A. Okay, so let me just show you. Though we have done this, suppose you have A equal to A, B, C. Okay, let us take these three elements. Now power set of A will contain all the subsets of A. So all the subsets of A will be, one subset will be A, then B, then C, then you can write here set containing AB, then set containing BC, then set containing CA, and the whole set you can take ABC, and finally you can take 5 also. Okay, so how many elements in power set? The elements of the power set is the set of all possible subsets. I mean, the elements of the power set is all the possible subsets of A. Okay, so A has 3 elements. Number of subsets is 2 to the power 3. It means number of elements in power set of A is 2 to the power 3. You can count in case you are missing something. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it means if number of elements in A equal to n, number of elements in power set of A equal to 2 raised to the power n. Okay, so it is based on the concept of finding all possible subsets. Okay, so once you are familiar with how to find the subset of A, so you can take, how to get power set of A. So here you may get questions like this: find all the subsets of A. If the question is find all the subsets of A, suppose let me take one example. Okay, here in question number 4, though we have taken most of the questions. Suppose you have AB. Okay, set A, AB. The question is find all subsets of A. So if it is subsets of A, then you can write subsets of A. You may write one subset is A, another is B, next one is AB, then fourth one is 5. A has 2 elements. It will have 4 subsets. So if the question is power set of A, find power set of A, then what you have to do? You have to take all the subsets as element of the power set. Then we can write A. So you have to see the language of the question. Okay, so here I am including power set also. Otherwise in the book it is written find the subset of A. So find the subset of this set means this will be the answer. Answer will be written like this. You have to write only subsets. But if the question is find power set of A, then you have to write what? All the subsets enclosed within the curly bracket. Clear? And if the question is how many non-empty subsets will it have? Okay, how many non-empty subsets means 5 will not be included. It will be 2 square minus 1 means 4 minus 1, that is 3. Okay, so I hope the concept, we have studied today is clear to all of you. Yeah, so we have studied what? We have studied what is a subset. Okay, then superset, and of course, proper subset, proper superset included. We have studied universal set, and we have studied power set also. Power set. Okay, so these four concepts we have studied. I'm sure it's very, very clear to you. And also how to find subsets of a given set, how to find non-empty subsets of a given set. Okay, and we have covered most of the questions from exercise 1.3 of NCERT textbook. Okay, and in next class we can continue with universal set we already covered. Next class we'll continue with subsets. Okay, subsets intervals basically. Okay, so intervals are subsets of real number. Okay, so basically in short I can say next class we can start with intervals, then we can study Venn diagram. Okay, and related questions. So thank you so much.